Okay, so and I want to talk a bit about materials and in particular something called graphene. Now the reason I'm doing this is because we tend to focus especially over the last decade, we have tended to focus purely on things like AI, software, when we think technology. But really what you will see in the 2020s is basically materials advancements enabling other major breakthroughs. And graphene is actually one that's been predicted for a very long time, and it was only really discovered in the early 2000s. So what is graphene? Well, the story is actually quite funny. Graphene is an allotrope of carbon, but it's a material that is actually just one atom thick, right? Some people even call it a two-dimensional material because it's so thin. It's literally one atom thick. And of course, the idea is that you can create a sheet of it. And it was actually discovered by accident when I think somebody had two researchers at the University of Manchester put a piece of sticky tape on graphite, and when they lifted the sticky tape off, it pulled out that very thin material, and they found that that was actually graphene, which had been theorized for many years prior to that. Now, what is so important about this, and why will this help us with all the cool tech we're looking forward to in the 2020s? So firstly, this is one of the strongest materials known. It's 200 times stronger than steel. It's also one of the best conductors out there. It's a superconductor for both heat and electricity. I mean, it sounds funny when you think about a non-metal being a fabulous conductor, but that's exactly what this is. Now, graphene, due to its strength, due to its conductivity, being super thin, is going to help us. It's the breakthrough that we needed for a whole host of things. So the first will be Moore's Law. Now, as you know, in order to process even more amounts of data, in order to bring AI to the edge, and even away from the edge on normal PCs, we just need to keep going. We need even more performance. And if you look at the current state of the CPU, we are at about 7 nanometers, and I think Intel is still on 14 nanometer as I record this. There's a bit of disruption going on there. TSMC have actually leapfrogged them, but I think the Intel will catch up. But that's kind of where we are, and the roadmap takes us to all the way to 2 nanometer, 1 nanometer, based on current silicon. And yes, quantum computing is coming, but that's something else. In the meantime, we really are about to hit a limit on conductivity, heat, size, and things like that. So a material, a super material like graphene, it's a superconductor, super thin, literally an atom thick, and very strong, could enable us to design the next generation of chips, non-quantum chips, but potentially even chips to be used in quantum computers as well. And this is really exciting. If you follow the history of graphene, urge you to do a bit of reading up on it. So it could do that. Due to its sheer strength, it could be used to build a space elevator, okay? And that will solve the problem of lifting up into space. We could get better batteries. We could get a whole host of things. There are some downsides, obviously. We don't know how we're going to produce it at scale just yet. The other thing is that it's such a good conductor, it cannot be stopped or gapped in order to create a transistor. And I think that's the next big breakthrough. I think once we can create a transistor out of graphene, the floodgates will open, and that's going to be really exciting. Then once again, materials breakthrough will enable the underlying hardware breakthrough that is needed for what we can envisage. We know what we're going to do on the software side, on the compute side, theoretical computing. We need this breakthrough to catch up. There's also some talk that this will be used to store hydrogen, and I'm going to talk a little bit, I might as well talk about it now, about hydrogen cars. I don't think in the 2020s, since I'm making these predictions, I don't think electric cars are going to be the be-all and end-all. I think there are some problems, some of which are obvious. How do you generate the electricity, for example? In a country like South Africa and many other developing and third world countries, electricity supply is a problem, and that which is supplied comes from coal. It's not really clean. And then there's the engineering aspect as well. You'll notice that the electric cars that have been successful have been on the high end, like your Teslas, and now you have Porsche. But the really affordable electric cars haven't been that successful. Nissan Leaf, Chevy Bolt. So it's been a bit of an image and a status thing. And it also meant that you never really had the scale yet. And with electric cars and current battery technology, these batteries are very heavy. What about component reliability? It creates a whole bunch of engineering challenges. Yes, there may have been people in first world countries on really great roads with really great maintenance infrastructure using their Teslas and doing fairly high miles at the moment. That isn't necessarily going to be transferred to the third world. So in the 2020s, you will see advancements in battery technology. You will see hydrogen cars, I'm predicting, make a comeback. They've been going slowly and under the radar in places like Japan, where you have two models. Toyota's now in their second generation. I think it's called the Mirai, and Honda launched the FCX, and they're building the infrastructure. The Japanese are building the hydrogen infrastructure. Remember, the waste product of hydrogen is just water vapor. Okay, so this is very exciting. Now, materials breakthroughs will enable us to do all these cool things, not software alone. As much as I'm a software guy and I love that. So graphene I use just as an example of the tremendous materials breakthroughs that we hope to see in the decade of the 2020s. Graphene itself should finally start realizing its value, especially if they can figure out how to do transistors and gap it and stop, open the conductivity and stop the conductivity at will. And I think that for me is going to be really, really exciting. The various types of materials breakthroughs that we will see in the coming years.